Hello and good day everyone. We are from Group 8 and I'm going to represent my group to open this video presentation. My name is Zhou Cham Dan Xiang Sen. I would like to say thanks to our lecturer for giving us opportunity for conducting this video presentation. In this video presentation, our group are going to talk about the introduction of heat transfer, convection, conduction, radiation, and the conclusion of heat transfer. First, we will talk about the introduction of heat transfer. And now I'm going to talk about the introduction of heat transfer. The passage of heat, also known as thermal energy, causes by temperature difference as well as the following temperature distribution and variation is referred to heat transfer. The movement of internal energy from one substance to another is also known as heat transfer. The study of heat transport and the changes that occur as a result of it is known as thermodynamic. Understanding the heat transmission is essential for comprehending thermodynamic process like those found in heat engine and heat pump. The transmission of thermal energy due to the temperature gradient is also known as heat transfer. The internal energy of a substance generated by the motion of individual atom or molecule according to kinetic hypnosis. Heat energy is a type of energy that allows energy to transfer from one body or system to another. The heat transfer can occur in variety of ways including the exchange of momentum, energy and the mass in the form of conduction, convection, and radiation in this subject of transport phenomena research. Mathematical formula can be used to describe this process. Conduction is a slow process that involves the transfer of energy and entropy between nearby molecules. And convection is the movement of a heat fluid such as air over a short period of time. Radiation is the process of transmitting energy as an electromagnetic radiation from an emission at a heated surface to its absorbed and another surface without the use of a medium.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Amirah binti Yusof. For this part, I will explain about heat conduction. What is conduction? Conduction is defined as the process of transmission of energy from one particle of the medium to another with the particles being in direct contact with each other. Conduction happens when an area of higher kinetic energy transfers thermal energy towards the lower kinetic energy area. High-speed particles clash with particles moving at a slow speed. As a result, slow-speed particles increase their kinetic energy. This is a typical form of heat transfer and takes place through physical contact. Conduction is also known as thermal conduction or heat conduction. The rate of conduction can be calculated by the following equation, where Q is the transfer of heat per unit time, K is the thermal conductivity of the body, A is the area of heat transfer, T hot is the temperature of the hot region, T cold is the temperature of the cold region, and D is the thickness of the body. For the experiment part, I will be conducting a heat conduction experiment with hot water. The equipments that we needed are hot water, 3 mugs, butter, and 3 types of spoon, which are wooden spoon, plastic spoon, and metal spoon. For the first part, we need to boil the water for a few minutes. Then, place a small pat of butter at the top of metal spoon and put it in the mug. Repeat the process with plastic spoon and wooden spoon. Next, carefully pour hot boiling water until it is almost completely full in each mug. Lastly, watch carefully to see what happens to the butter on top of each spoon. You will likely need to wait for a few minutes to see the result. As you can see that the butter on the metal spoon has melted significantly, but the butter on the wooden spoon and plastic spoon barely melted at all. From this experiment, I can conclude that metal is a good conductor of heat, while wood and plastic are good insulators. A conductor transfers thermal energy well, while an insulator does not transfer thermal energy well. That's all from me. Thank you.
Hi and a very good day, doctor. My name is Leong Pei and my matrix number is CV200193. And now I'm going to present about the convection part. Introduction. Convection is defined as the movement of fluid molecule from a higher temperature region to a lower temperature region. Next, convection, we can also know as convective heat transfer, is the movement of fluid that transfer heat from one place to another. Third, convection is often discussed as a separate method of heat transfer, but it actually involves the combined process of conduction, we also know as heat diffusion, and advection, heat transfer by bulk flow. Lastly, convection is the most common mode of heat transfer in liquid and gases. Convection can also lead to circulation in a liquid, as the diagram in the left side shows one of the heating of the pot of water over a flame. The heat water will expand and it will become more buoyancy. The cooler the water, the more dense the water will near the surface descend and a pattern of circulation can be formed. And true, it will not be as regular as suggested in the drawing. Example of convection. One of the example of convection is the space heater. Space heater is a classical example of convection. As the space heater heated the air around it near the forces, the air temperature will rises, expand, and it will rises to the ceiling. This forces the cooler air to be down and it will heat it, resulting in a convection current. Now, I would like to show you how I conduct the conduction experiment. The idea of the conduction experiment, I get it from the internet and YouTube. Let's see how I conduct the experiment. Let's go! First of all, we need to prepare the apparatus as below. The first thing is a cup that contains with rice. The second thing is the candle. The third thing is the lighter, the scissors, the pencil, the jigsaw map, and the last one is a piece of paper that we have drawn it as a fence or vents. The first procedure is by using the paper we just now draw it as a shape of vents or fence. You need to use a scissors to cut out the circular shape like below. Then, this is the output shape when we cut it out by using a scissors. Next, we need to use a cup that consists of rice, and then we need to prepare the apparatus such as a pencil and put the pencil inside the cup that consists of rice. The purpose of putting the rice into the cup is to make sure that the pencil is in a stable condition. Next, we need to use the paper that we just cut it and put it on top of the pencil. And the shape will look like this to make sure it stays on the vent, and the shape is look like this. Furthermore, we need to use the candle and put the candle around the cup. 1, 2, 3, and 4. After that, we need to use the lighter to light the candle around the cup. And now the candle is already lit out. We can see that the vents, it will blow slowly by slowly and it will rotate. By this experiment, we can show that when the candle are lit up, the air in the vicinity of the candle heats and bring the lighter, the air rises and causes the cold air to move out of the stick. This movement causes the to rotate. Thus, it indicates the flow of convection current in an upward direction.
Hi, my name is Jonas Merdan, and in this part I'm going to talk about radiation in heat transfer. So what is actually a radiation? So radiation can be defined as a radiant heat which represent in some sort or other form in our daily life. Thermal radiation are referred to as a radiant heat. Thermal radiation is generated by emission of the electromagnetic wave. These waves carry away the energy from the emitting body. Radiation takes place through a vacuum or transparent medium which can be either solid or liquid. So thermal radiation is the result of the random motion of a molecule in matter. The movement of the charged electron and proton is responsible for the emission of electromagnetic radiation. Let us know more about the radiation heat transfer. So as for the equation, thermal radiation can be calculated by Stephen Boltzmann, where we can see that P is actually equal to net radiated power, A is a radiating area, sigma is Stephen constant, E is emissivity, which is 1 for ideal radiator, T is temperature of radiator, and lastly Tc is temperature of surrounding. Now on to the experiment part. So the experiment going to be the absorption of thermal radiation. Moving on for apparatus. For this experiment, we only going to need cover cap and thermometer. So in this video, before I'm going to start the experiment, I'm going to take the temperature first just to make sure that both of these caps have the same temperature before I'm letting them sitting into the sunlight. So now what I'm going to do is I'm going to place them under the sunlight and letting them sit under the sunlight for about a minute and to see which of these caps have the highest temperature. So based on the theory that the black color cap going to have the highest temperature compared to the light cap. So for now we're going to see and wait. So after 1 minute, here we can see that the black cap is actually has the highest and increased drastically in temperature compared to the white cap. So for now I'm just gonna let them sit again under the sunlight for about a minute and see if there is any kind of drastic increases between these two caps. So finally, after 2 minutes and 20 seconds, it seems like the black cap has the highest temperature compared to the white cap, and that's because as far as we know, the black color actually absorbs all wavelength of light and converted them into heat, which is why the black cap increased temperature drastically, while for the white color or lighter color on the other hand, it reflects all the wavelength of light so that the light does not convert into heat, and that's why the temperature of the white cap increase slowly. So after the end of this experiment, I can finally conclude that the black color are both extremely good of absorber and also good emitter of heat radiation compared to the lighter color. So that's all pretty much for me. Thank you so much.
And finally, we have reached the end of our video presentation where I'm going to talk about the conclusion of this whole video presentation. Conclusion. As you can see from the video that our group have created or made, the heat transmission occurs everywhere around us. Although it may go unnoticed, it has a significant impact to our life. The study of thermal energy flow is also known as heat transfer. Conduction, convection, and radiation are the three types of heat transfer that our group have learned. When physical parameters are temperature sensitive, the fluid flow and heat transfer problem can be strongly connected thanks to the convection factor in energy equation. The source term can be introduced into the enthalpy equation as a result of chemical reaction like combustion. While analytical solutions exist for some simple issue, the majority of industrially important applications need the use of computation method. And this is the end of our group video presentation. Thank you for spending your time listening to our group video presentation. Thank you.